5G gives enterprises the opportunity to develop new ways to bring unique products and services to market with greater efficiency. To achieve this vision, communications service providers, or CSPs, need to create and deploy services that satisfy a wide range of application requirements, all on a shared network infrastructure. Network slicing can answer this call, enabling greater flexibility to adapt to these demands. But how does slicing work in practice? A target customer, for example public safety, may require different applications, each with unique communication requirements. Together, these requirements form the Service Level Agreement, or SLA, between the customer and the CSP. The CSP will create a network slice based on the SLA. The service orchestrator in the CSP's network works with controllers for the RAN, core, and transport to automatically set up slices of network resources in each of these domains. These connect together to form an end-to-end slice of network resources, from the end-user equipment to the data center where the application is running. Focusing on the IP routing transport domain, the Nokia Network Services Platform, a software-defined networking platform, uses its transport slice controller function to set up connectivity for the public safety transport slice between the RAN and the core endpoints. It does this by setting up services, tunnels, and paths using, for example, EVPN over traffic-engineered segment routing tunnels. The routers in the path will allocate resources to this service to create the transport section of the end-to-end service slice. This full automation not only saves operational costs, but also provides a fast and accurate service setup. Each application in the public service slice has its own class of service and is prioritized, shaped, queued, and scheduled as appropriate based on the SLA. Each slice is guaranteed its own SLA across the transport network, keeping the traffic on each slice separate and preventing competition for bandwidth or priority. An SDN function that will be critical for 5G is automated traffic engineering. In this example, we're using segment routing, but other techniques such as RSVP-TE are available. Using its path computation element function, the NSP computes the best path across the backhaul network for each of the customer's 5 applications based on their requirements. For each of these paths, the PCE downloads a service label and other routing labels to the ingress router. The service label identifies that it is one of the applications of the public safety slice. These labels can be general, or they can be specific if you have load balancing or latency requirements. When the packet arrives at its destination, the DC gateway router removes the last label, reads the service label, and processes the payload, forwarding it on to the public safety application. By automating SDN-based traffic engineering to create end-to-end backhaul paths, time and cost are reduced, making it far more efficient than manually setting paths at every node. If a fault occurs, the adjacent network routers will detect it immediately and will use a local fault recovery technique, such as the topology-independent loop-free alternate, to reroute traffic to the best available alternate path. The routers report the changing conditions to the NSP at the same time. Should there be an issue with this new path, the PCE will compute an alternative path that meets the SLA requirements, downloading a new label stack to the ingress node. Nokia IP routers have a scalable statistics collection infrastructure with counters tracking performance metrics, such as delay, jitter, and packet drops. They continuously report these metrics via telemetry to the NSP. With a full end-to-end view of the transport network, the NSP can automatically react to changing network conditions, proactively avoiding congestion while ensuring optimal routing performance and effective network utilization. SDN automation is critical for 5G service creation, and IP routing innovations work together to provide a flexible platform to support new 5G era services. Together, they provide everything you need to accommodate future application requirements and capitalize on new 5G business opportunities.